Welcome to the Blue Security Podcast, a weekly podcast for information security defenders, where we bring you discussions on best practices, tools, and implementation for enterprise security. Now, here are your hosts for today's show, Andy Jha and Adam Brewer.
Welcome to this week's episode of the Blue Security Podcast. I'm Andy, your host.
I'm Adam, your co-host.
So this week there was a vulnerability that had a lot of chatter on the InfoSec Twitter. It is CVE 2022 30190 or 30190. Yep. Microsoft Support Diagnostic Tool Vulnerability, and it was dubbed Follina before it was given a CVE. Now, Adam and I are full-time Microsoft employees, so we do have some talking points, but the MSRC blog on this is actually very, very good. It goes through kind of what it is and what some of the mitigations are. So the vulnerability is something with the MSDT URL protocol, where the URL can grant remote execution code without user interaction. And furthermore, if the file that the code is executing from is saved in rich text format, or RTF, the Windows Explorer preview pane can execute that without user interaction. Now, if it's rendered within Office applications, then if you're using it in protected mode or Office Defender Application Guard, those will block it. But the concern is this non-user interaction remote code execution. So the MSRC blog says you should disable the MSDT URL protocol, which does prevent some troubleshooters from being launched. And that could be an issue in the long term, but probably not in the short term. But the troubleshooters can still be accessed through the Get Help application within Windows. And to do this, you can delete the registry keys. Of course, we'll put the blog in the show notes, and there's a detail walkthrough of which registry keys that you need to delete in order to remove the URL protocol. It also tells you that you should back up the registry keys so that you can restore it later on. Another thing that you should do is disable the preview pane for Windows Explorer, or you can disable Windows Search. So one of the things that the cyber criminals are trying to do is use like a phishing campaign that will automatically launch Windows Search when they open up the document, and then it'll launch into the malware through the preview pane. So you can either disable Windows Search or disable the preview pane in Explorer to get rid of it. And of course, like I mentioned, Protected View and Application Guard for Office does protect against this if it's opened up within those applications, but if it's not, then it could execute. AV detections and signatures have been updated to detect it. EDR detections have also been updated to include suspicious behavior for Office applications and suspicious behavior for the MSDT.exe, which is what gets executed to launch this URL protocol. And finally, you can implement the attack surface reduction rule, block all Office applications from creating child processes.
So that's a good summary of all the mitigations you can take, and hopefully you've already implemented them. But if you haven't, here you go. My thought on this was really I have a beef with how this was reported. And my perception was that there is a former Microsoft FTE who has made it really clear that he is an axe to grind for some reason. Reported this out just very publicly on Twitter, and was kind of like, yeah, I tried to report it and they didn't believe me. So here it is, public disclosure. I've talked on this show many times that while the goal should be perfect code, perfectly secure environments, and perfectly secure OSs and applications, that is an unreachable goal. So I believe extremely strongly in proper disclosure. Disclosing something privately to the company and allowing them a valid length of time to, patch it before it's publicly disclosed. And just because they say, no, we don't think this is an issue the first time, you don't go, oh, well, forget you guys. And by the way, I hate your economic model, so I'm just going to announce this publicly. And maybe I'm getting some of the details wrong, but that's my perception of how this went down. And I just want to say, and I don't know if we have a ton of security researchers listening to the show by any means, but if that is a business you go into, you don't get to choose, like, I'm going to not properly disclose this because I used to work for that company. I don't like them. Or I don't like that company's economic model. I don't like how they make money. I don't like what they choose to sell versus what they choose to bundle or the cost of their products. That's not how it works, right? And so this is just, it's really important to me. And I just kind of wanted to use my tiny little platform of the world to vent here, that I got kind of fired up about this. And again, like, stuff like this is going to happen in Mac OS, in Android, in Windows, but proper disclosure helps keep everyone safe as long as possible. So I don't like the way this all went down. Their mitigations are there. The Microsoft, the MSRC, it has some great resources on how to mitigate this. Your EDR vendor, your AV vendor probably has detections now. So for the most part, we're in pretty good shape here on mitigating this. There'll eventually be a patch to Windows that will eliminate basically the sanitization that's not occurring with that URL handler, and life will go on. But just kind of wanted to get on my soapbox about that too. And one last note as well, like, maybe these aren't waters I want to wade into tonight. We'll save that conversation for another time. Let's move on to the zero patch, Andy.
Yeah. So as you said, Adam, there isn't a patch for it yet, and there are mitigations out there and detections. Microsoft is probably racing to patch this now, but for the moment, if you want to patch it, there is a legitimate place, although it's unofficial, a place called Zero Patch, and they've been releasing micro patches for a long time. They released a patch for this particular vulnerability. It is free, but you do need an account with them, and it does require an agent in order to install their patch. And so if that's of interest and you think it's an issue and you're not able to, scope some of these mitigations right away, Zero Patch does have an unofficial fix for it already. But on to the main topic for tonight. This is something that is part of the Windows defense that we haven't actually talked about yet. We've talked about some of it way, way back in our ransomware episodes, but Windows Defender Exploit Guard is part of a very comprehensive device hardening solution that you can implement that is included in Windows. The ASR rules, or attack surface reduction rules, that is part of this fix is part of Windows Defender Exploit Guard. First off, let's talk about licensing. You do need to be on Windows Enterprise or EDU in order to use this. Most of the licensing and the documentation calls out for Defender for Endpoint Plan 2 or Plan 1, or Windows Enterprise, Windows EDU. So make sure that you have the correct licensing, because the security features are part of what makes Enterprise and EDU more secure than Windows Pro. Defender Exploit Guard is made up of several components, and they may not even use that particular term anymore in marketing. I still use it because that's what we used to call it, but it's made up of several components, like hardware-based isolation for Microsoft Edge, which we talked about in the application guard container. So containerizing Microsoft Edge. Application control, which was Windows Defender application control, which we also had a show doing a deep dive on that. The other four: in control folder access, network protection, exploit protection, attack surface reduction rules. Those are the 4 that we're going to do a deep dive on tonight. And then finally, Windows Defender Firewall, which we will have an episode on, just not going to do a deep dive on tonight. So the 4 that we're going to go over, we'll start with the ASR rules, because that is very prevalent and timely for this exploit out there, this vulnerability. So the ASR rules, you do need to be on server 2012, R2, or Windows 10 1709 or higher. And that's for the majority of these features as well. So that's kind of all up. Attack surface rules target certain software behaviors like launching executables, files, scripts that are attempting to download or run files, obfuscated scripts, suspicious scripts, apps that don't normally initiate during normal day-to-day work. And so there's a ton of different rules. I highly, highly recommend that you look at the documentation that we're going to link in the show notes, because it has a list of all the rules and what it's there to do or help you prevent. You can run any of these rules in audit mode. You can deploy it using PowerShell, group policy, or Intune. There are a couple of caveats. So because Windows attack surface reduction rules use Defender AV for enforcement, Windows Defender AV must be enabled and used as the primary AV in active mode. So that does mean that if you're using a third-party EDR or AV solution and that's doing the enforcement for you, then you won't be able to use most, if not all, of the ASR rules. Additionally, you want to have cloud-enabled protection enabled, which I would recommend to do that anyways, even if you're not using the ASR rules. And then if you have a bunch of developers, some of the rules don't really work that well if you have a lot of unsigned, internally developed application or scripts that are in high use. It is a lot more difficult to deploy ASR rules if code signing is not enforced. So that's another caveat. But again, you can run all of this in audit mode and then inspect the events and see how many things are getting blocked. You can plan your deployment, very similar to any type of rollout project, right? Scope which rules you want, put them in audit mode, assess what is getting blocked, put in some exclusions, and then move on to enforce them. Some example of the rules are like what we talked about: block all Office applications from creating child processes, block credential stealing from Windows Local Security Authority Subsystem, or LSAS. And you may be like, hey, doesn't Windows Defender Credential Guard do that? Well, some organizations can't implement Windows Defender Credential Guard due to maybe some compatibility issues. You can use the ASR rules to do the same thing. But again, remember some of the caveats with the ASR rules. But you can do the same thing if Defender Credential Guard is incompatible with your environment. Other things like block executable content from email clients and webmails, like .exes, .dlls, script files like PowerShell scripts, Visual Basic scripts, JavaScript. Like, these are some basic things that, like, you're looking at it and you're just like, this makes sense for me to implement some of these ASR rules. So take a look at the rules. I highly recommend, if you are able to and meet some of the prerequisites, to start testing some of these and rolling them out.
What was the tool in Windows 7 that was the equivalent to this? Do you remember what that was called?
Yeah, so that is actually part of exploit protection, which we'll talk about, but it is EMET.
Yes.
The Enhanced Mitigation Experience Toolkit.
Yes. Okay. That's what I was trying to think of. So, okay, that's more of the exploit protection stuff. Got it.
Correct.
I just remember in the early days of Windows 10, and people called that different things are pronounced in different ways. Like I think you said EMET. Some people called it EMET, more like the name, the person's name. Anyhow, I just was trying to map that here. So this is, attack surface reduction. There were I think a little bit of this in Windows 7, but obviously way more robust in Windows 10 and Windows 11. And really, really, really powerful stuff here. But I think you mentioned there's the ability to run a lot of this in audit mode initially. So you can get a feel for like, hey, if we turn all this on, how bad are we going to get blown up on this stuff? Do we have something internally that's going to light this up? And we might want to, manage that at first. So I think there's options to get there. But we talk all the time on this show about like doing the basics. I mean, like we bang the drum on this all the time. Just do the basics first, do the basics. Like this is the basics right here. So certainly there is effort involved in configuration and tuning of these things, but this is work worth doing, because if you had some of these ASR rules turned on, even when this new MSDT thing came out, if you had turned on like prevent Office apps from creating child processes, you're already somewhat protected, right?
Mm-hmm.
Yeah,
absolutely.
So, that's why should Office apps be able to spawn child processes? Like, I don't want them to. So this is a natural, a great real world example of, for orgs that did their homework, they weren't sweating a whole lot earlier in the week.
Oh, you have to cut that out or mute it.
I didn't hear anything.
Were you finished there? Sorry.
Yeah, I'm good.
Oh, okay. Sorry, you'll have to cut this out here because my kid just like walked down and should I just move on to the next one?
Yeah, I'm ready. Let's move on to controlled folder access.
Okay. All right. Sorry. So the next one that we're going to talk about is controlled folder access. And this was the one that we had talked about during the ransomware episodes, because this is a specific feature to mitigate against ransomware. So what controlled folder access does is that it looks at folders that are trusted and then only allows trusted apps, which are on another list, to make changes to those protected folders. So if it's not on the list of applications that is trusted, then you're not able to make changes. So for example, if I have my documents folder, and that's a protected folder, and I have Word as a trusted application, Word will be able to make changes within that folder. But if I have some Conti ransomware, some suspicious process executable, and it's not on the trusted apps list, then it won't be able to make changes within that folder or encrypt it. So the Windows systems are protected by default, and you can't remove them from the list. Again, you can run this in audit mode. The common protected folders are like the documents, the pictures, the videos, music, favorites. You can add more folders if you wanted to. This is something that does also require tuning. So again, you can run this in audit mode. You do need to have Defender AV real-time protection turned on. So again, this is one of those features that probably needs the Defender AV to be your primary antivirus agent. You can deploy through GPO, Intune, or PowerShell. So very powerful thing. I have tested this before. I will tell you it is one of the more invasive features. So I wouldn't deploy this to like all of your users. It could be very productivity inhibiting. But for high risk or critical systems, this would be something that I would absolutely take the time to scope out, right? This is one of those things that Adam and I talk about where it may not make sense for all of your users, but it definitely will make sense for some.
Yeah, I totally agree. It's one of those things where you may have higher risk users, or you may have users that have simpler needs and have more predictable use cases, and it would be easier to implement. Like opposite ends of the spectrum. I have these users that use an extremely locked down set of apps. They're a call center. They need these 3 apps and that's it. Okay, controlled folder access might be for you in that use case, because much simpler to implement than somebody who might use any random app. Or on the opposite end, I want to build some sort of hardened workstation, like a paw or a saw, You might want to use something like this in that scenario. So I think still, anytime you reduce attack surface, it's worthwhile. Just because this doesn't apply to all use cases doesn't mean it's not worth doing.
The third one is exploit protection, which we kind of alluded to when Adam was asking about EMET, the Enhanced Mitigation Experience Toolkit. And if you're familiar with Windows 7 and Windows 8, this was like an add-on thing that you could do to harden your systems. There are some examples of policies like arbitrary code guard, block untrusted fonts, validate API invocation. There's a lot of different ones. This is more, almost like more system level or kernel level protections, whereas I would say the ASR rules are more of on the application layer, but also worth looking at. You can run these in auto mode as well. You can actually enable these locally through the Windows security application, or again, through Intune. This one can be deployed through SCCM or Microsoft Endpoint Configuration Manager. It can also, again, be done through group policy or PowerShell. So worth looking at. If you're familiar with EMET, you can actually import some of those rules from EMET into Exploit Guard directly through an XML file. And then the final one is network protection. And so what network protection does is it expands on Smart Screen. Smart Screen is meant for web pages and downloading malicious files. So if you've enabled this, which again, I highly do recommend that you do because it's a built-in feature and it's based off of reputation. So if it sees something, it can just pop up, and users can usually override them as well if you have a more lenient policy. But this expands on it where it blocks all outbound HTTP and HTTPS traffic that connects to low reputation sources based on domain or host names. So it extends that web protection to the operating system level, right? And it's all reputation based. So it does work off of the threat intelligence that Microsoft provides, but there is a way to submit false positives or false negatives. And then, of course, you can add your own exclusions if you need to. If something pops up and you don't have time and you need to do it, you can add an exclusion. Again, you can run it in audit mode, just like the rest of them. You can review the network protection events in the event viewer, just like with all of these other features, and then deploy it again very easily, again, through PowerShell, Intune, GPO, or SCCM. So yeah, that's all of the features for Defender Exploit Guard that we wanted to talk about tonight. Again, there is one other one, which is the Defender Firewall, which...
it's a bigger topic.
You know, it is a bigger topic, and we'll do a deep dive on that in one of our later episodes. But this is something that is built in with Windows for most of you who might be listening who are enterprise customers. If you're using Windows 10 Enterprise or Windows 11 Enterprise or EDU versions of them, or servers, you know, these are all built in to those operating systems and can be configured. I will say a lot of them are a little bit more heavy-handed, so definitely do your testing, do your audit, but I think they are definitely worth it.
Yeah, absolutely. I mean, it's built into the OS. They're incredibly powerful. We gave a real world example tonight on leading the show with kind of the latest, security story of the week, and how had you done some of these attack surface reduction rules, you were already pretty well protected. So just a great example on how doing a little bit of homework ahead of time pays dividends later. So this is really nice because it ties in with all the other shows we've done on the security features built into Windows. We've done a lot of those just because, again, people don't know about them. And so if you like the content from tonight, if you're like, oh, this was cool to learn about ASR and exploit protection and network protection, then go back and check out our catalog, because we've done other shows on things like Windows Defender Application Guard, Windows Defender Credential Guard, and some of these other security features that are built into the operating system that you may already own and maybe in your environment trivial to deploy or relatively straightforward to deploy. For some orgs, deploying Credential Guard doesn't have to be a huge deal, as an example. So if you like tonight, go check out some of those other ones too, because there's a lot there built into the Windows OS. And I will say, before I came to Microsoft, I didn't know about any of this stuff either. Like, I was shocked at how much security capability is built into the OS that you don't need to go procure anything else for, and can really, really, really help you harden your environment, but do so in a way that's not negatively impactful.
Yeah. I read something on Twitter where this person was saying, Windows is actually one of the most secure operating systems out there because we've invested so much into the security of it. Mm-hmm. What happens is that there's all these things that are there and not everybody turns them on. And that's just part of being, in a large organization where we have to try to cater to all the different kind of customers that are out there, right? And so there's organizations that may need this feature, but then there's other organizations that are like, yeah, we don't really need it, or it's too much to deploy, or it doesn't work in our environment. And so they're there. Part of what was the security story for Windows 11 was we were turning on some of these by default, and that was new. Right? Whereas right now in Windows 10, if you're still in Windows 10, these are all optional. You can turn them on, but then in Windows 11, some of these features were getting turned on just by default. So
right. If you've heard the term like secured core PC, what that means is a lot of like the hypervisor based security controls in Windows are enabled by default. That's how it ships out of the box. You turn it on, it's already configured that way. And that's where, we could get on a real slippery slope here. And we say, that's why you want to do things like autopilot, and you want to use that known good OS that's already configured in a hardened state by the OEM, and just layer in your security controls and your apps on top of it. But maybe that's another story for another time. But it's interesting how it all ties together. And I think your point is sound that, Windows is used on over 1 billion devices, and each org is going to have different methodologies for deployment, different security standards set and enforced, and different methods of doing those. But if you do things the right way, and you really start with a fundamental operating system and use the native controls to harden it, you can get to a very, very secure state. Now, the bad guys are always trying, so we got to stay one step ahead. But this stuff you can deploy here, it's good stuff. So check it out.
And that's our show for this week. Thanks for watching and listening as always. Our contact information will be in the show notes if you guys have any questions or topics you want us to talk about. Thanks, and we'll talk to you next week.
Thank you for listening to the Blue Security Podcast. Please check out the show notes, catch up on episodes you may have missed, and subscribe so you don't miss any future episodes. Find Andy on Twitter @AJaw0 and Adam @AJ Brewer. See you at our next episode.